Hello everyone, we are presenting our civil prototype project based on a bamboo chair designed using the fish mouth joint technique. Our project focus on creating a sustainable, strong and cost-effective furniture solution using a bamboo as a primary material. So in our project, our group members are Atharva Jagdane, Sagar Panchal, Vivek Jogdande, Samit Pisar, Om Korde, Rajnandini and Purva Mari. So this project was completed by our group as a part of batch A4, and today we all talk you through the concept, problem statement, and our approach. Let us start with the introduction. Our project is based on sustainable approach to furniture design using bamboo. Unlike traditional materials, bamboo is renewable and grow very fast, making it an excellent alternative. One important point is that bamboo has a high tensile strength, which is actually comparable to steel in some cases. This makes it sustainable for structural applications like furniture. In our project, we didn't just build a chair, we also include structural analysis and design modeling to understand how much load it can carry and how forces are distributed. From a border perspective, this project connects with the eco-friendly development where we reduce environmental impact, and also with the civil engineering, we apply analysis techniques to real life prototype. Overall, this is a prototype scale model mainly for academic understanding, but it reflects real world application. Now let's look at the problem we are trying to solve. Traditional furnitures mainly uses wood, metal and plastic, which are resources intensive and not sustainable in the long run. First issue is non eco-friendliness. Materials like plastics and metal contribute to pollution and long-term environmental damage. Second is a high material cost. Conventional furnitures materials are expensive, increasing product cost. Another major issue is heavy weight and transportation cost, making furniture difficult and costly to move. And finally, deforestation, excessive use of wood leads to cutting down trees, which harms the environment and biodiversity. So our solution is to replace these materials with bamboo, which is lightweight, cost effective, and sustainable while still maintaining sufficient strength.
Now I will explain the proposed solution and objectives of our project. To solve the problems of traditional furniture, we are using bamboo as an alternative material. Bamboo is low cost and easily available in many areas, which makes it affordable. It is also eco-friendly because it is renewable and biodegradable material, so it does not harm the environment. Another advantage is that bamboo is lightweight, which makes the chair easy to carry and transport. It is also easy to work with as we can build the structure using simple tools and techniques. Most importantly, bamboo is strong enough for structural use as its tensile strength is comparable to mild steel. So, bamboo provides a perfect balance of strength, cost, and sustainability. Our objectives of this project has main four objectives. First, to design a bamboo chair prototype using basic structural principles. Second, to apply the fish mouth joint technique, which helps in creating strong and stable connections. Third, to perform load analysis to check whether the chair is safe under weight. And finally, to promote sustainability by encouraging the use of eco-friendly materials like bamboo. So our project aims to create a strong, affordable, and environmentally friendly furniture solution using bamboo.
Hello guys, myself Vivek Ignas Jogdande and I am going to present our project on a bamboo chairs scale model. First, let me explain the design overview. Our chair design is based on a two main engineering principle, load distribution and structure stability. This means the weight applied on a chair is evenly distributed across all parts, making it strong and safe. The chair consists of five main components. Front leg supports the front portion, back legs provides the rear stability, seat frame holds a sitting area, back support give a comfort and posture support across the support cross support increase the strength and prevent wobbling. These components together ensures the durability and balance. So now coming to the next part, We designed this chair using a standard economical measurement for a comfort. Overall height is 90 centimeters, seat height is a 45 centimeter, which is comfortable for sitting. Overall width is a 45 centimeter, seat depth is also 45 centimeter, given proper sitting space. From the side view, you can see how the backrest is positioned vertically and the seat is placed at an appropriate height for a user comfort. This design is suitable for full scale and means it can be used practically in real life, not just a model. That's it, guys. Conclusion is our bamboo chair design in a simple, strong, economical friendly and eco-friendly and based on a proper engineering.
Now, I, Atharva Jagdani, roll number 54, will explain the material used in our bamboo chair prototype. The main material is bamboo sticks, which act as the structural member. We selected the bamboo with uniform diameter to ensure proper strength and stability. For joining, we used Fevicol or PVA adhesive, which helps in creating strong bond between bamboo pieces. We also used jute binding threads, which is wrapped around joints to provide additional reinforcement, gives a traditional finish. To prepare the surface, sandpaper is used to smooth the edges and improve fitting of joint. Finally, we apply polish as an optional step to protect bamboo from moisture and insects and to improve appearance. So overall, all materials are simple, low cost and easily available. Coming to the next slide, fish mouth joint. So in fish mouth joint, let's understand the key construction technique used in our project, the fish mouth joint. In this method, a curved or a concave cut is made at the end of the one bamboo piece so that it fits perfectly onto the another cylindrical bamboo surface. This shape increases the contact area between two members, which helps better load transfer. Because of this, the joint becomes stronger and can resist shear forces more effectively. Also, this tight fitting reduces chances of slipping and improve overall structural stability. So, the fish mouth joint plays a very important role in making our bamboo chair strong, stable, and durable.
So the next slide is about the component list. This slide shows all the parts used to make our bamboo chair. First, we have front legs which are 2 in number. This supports the chair from the front and carry most of the load. Next are the back legs, also 2. These support the back side and also help hold the backrest. Then we have seat frame pieces which are 4 parts. These form the base structure where we sit. We also use cross supports 2 pieces. These provide extra strength and prevent the chair from shaking. After that, there are backrest bars, 2 in number. These give comfort and support to the person's back. Finally, we use thread and adhesive like Fevicol. These help in joining all parts together and making the chair strong. All these components are connected using fish mouth joints, adhesive and jute thread binding to ensure durability. Next slide is about construction process. This slide explains how we build the bamboo chair step by step. Step 1 is selecting bamboo. We choose straight and strong bamboo sticks of the proper size. Step 2 uh, is measuring and marking. We mark all the dimensions according to the design. Step 3 is cutting components. The bamboo is cut carefully and special fish mouth joints are made at the ends. Step 4 is assembling the frame. We create the main structure of the chair. Step 5 is attaching the legs. Front and back legs are fixed securely. Step 6 is adding cross supports and backrest bars to increase strength and comfort. Step 7 is applying adhesive. We use Fevicol and the joints with the cute with the jute thread for strong bonding. Finally, step 8 is finishing and testing. The chair is sanded, polished, and tested for load capacity.
Now I will explain the load calculation of our bamboo chair. We assume the weight of a person as 80 kgs. To calculate the force acting on the chair, we use the formula F is equal to m into g, where m is the mass and g is the acceleration due to gravity, which is 9.81 meter per second square. So the total load acting on the chair becomes 784.8 newtons. Since the chair has four legs, we divided the load equally, and the load per leg becomes 196.2 newtons per leg. So each leg carries approximately 196 newtons of compressive force. This calculation helps us ensure that the chair design is safe and can support the expected load. Now we will do the strength analysis of our bamboo chair. Different components of chair experience different type of forces. So the leg are mainly compression as they carry the weight of the person. The seat frame is subjected to bending since it supports the load and distributes it. The cross support experience both tension and compression, which helps maintain stability and prevents deformation. The joints, especially the fish mouth joints, are under shear force as they connect different members together. Based on our analysis, we conclude that the structure is stable and safe with proper load distribution across the all components.
Now let's look at the advantages and the limitations of bamboo chair prototype. Starting with the advantages, bamboo is lightweight, so the chair can be easily transported and handled. It is also lightweight, low cost, and easily available locally, making it economically available for construction. Another major benefit is that bamboo is economically friendly and renewable, which supports sustainable development. In terms of construction, it is simple to work with using basic tools, and importantly, bamboo provides good tensile strength as well as compressible strength, which makes it structurally reliable. However, there are some limitations. The fish joints required precise cutting, otherwise the strength reduces. The bamboo also sensitive to moisture and humidity, so proper finishing is necessary. Additionally, the natural variations in the bamboo size can affect uniformity, and it is not suitable for the large scale heavy loads applications. Next, coming to the conclusion slide. So, to conclude, a bamboo chair prototype is structurally stable under assumed load weight of 80 kg. The load is safely and evenly distributed across the four legs, ensuring the balance and stability. The use of fish mouth joint significantly improves the strength of connections by increasing the contact area and providing better shear resistance. Overall, the project demonstrates that the bamboo is not only strong but also sustainable alternative to conventional steel materials like wood and metal. So we can confidently say that the bamboo is an effective and eco-friendly material for civil engineering prototyping. Next, thank you for your attention. We hope you found our project informative. Thank you.